Hi, this is Rahman Sheikh. Welcome to Fortnightly Railway Transportation Systems podcast. I am the host and railway systems specialist working in this industry for 24 years and counting. This podcast is primarily focused on railway experts who have vast amount of experience and contributed greatly to this amazing industry. This is not a technical seminar but focuses on feel good stories, individual journeys, their success and failures, motivating younger generation to kickstart their career in railways and creating a sense of pride for the railway people who devoted their lives on the most environment friendly public transportation. Welcome to Railway Transportation Systems. Today, we are thrilled to have Malaeka Nadeem, the Director of Systems Engineering and Assurance at Sydney Metro, as our guest. With over 15 years of experience, Malaeka has been a key figure in shaping railway systems. She began her career at Thales in 2004 and her expertise has evolved through roles at Downer and Arup. Malaeka expertise lies in systems engineering and assurance, specializing in requirements management, traceability, configuration management, and operational concept diagrams. She is a driving force behind engineering change management and implementing FRACAS for proactive system analysis. Today, Malaeka will share insights into enhancing railway infrastructure through her extensive experience in Sydney's transportation projects. Let's welcome Malaeka Nadeem. Hi Malaeka, welcome to Railway Transportation Systems podcast.
Thank you, Rahman, for inviting me. I'm really excited to be here and answer your questions.
Thank you. So it's basically the whole point of doing this podcast is people get to know you and learn from your expertise. So let's start out with our first question. Can you tell me about systems engineering? Why systems engineering plays a crucial role in developing a railway transportation systems? Could you explain how systems engineering principles are applied in the context of railway infrastructure projects?
I think it's a good question to start with. I'm a systems engineer and I've always been a systems engineer. I started my career in systems engineering in the defense industries and I fell in love with the discipline. I find for me it's, in layman's terms, systems engineering is a process for engineering a system or realizing a solution that meets the client's needs or the customer's needs or the stakeholder needs, the people who are concerned with what they want to procure. And we talk about two parts of how do we define what we need in order to solve the problem space. And there's, do we build the right system and did we build the system right? And those two things have important context. And systems engineering comes up with those processes to enable that to occur progressively through the life cycle. And as we progressively working through the artifacts, we can then collect that artifact and demonstrate it at the end to meet the client's needs. You know, we have the beloved systems engineering V model that we all talk about. We start off with the needs analysis, stakeholder analysis, and then we move that into a system requirement specification and an operational and maintenance concept definition, which then talks about how does a system operate in the context. And in this area, I love to use the onion diagram where you have the system of interest in the middle with the hardware and software. Then you add the operator maintainer. Those two together meet the needs of the customer who uses the system, and that then sits in an environment or in a community that serves the needs of a particular community of an area. And so for that, systems engineering just is common sense. It makes sense. It's used across industries. And I think that it's such a universal skill set. If someone knows how to apply systems engineering, they definitely can apply it in the railway context. I think it's in the railway context, I think we've got a lot of maturity to go. If you compare it to where the defense industries is today, we do good requirements management, we do good safety analysis. We could do things better in RAM area. I guess in the software area, in the signaling space, it's definitely a lot better. But in other parts of the railway infrastructure, there's a way to go for improvement.
I do agree with you, Malek. What an answer. And that's the reason we need people from different industries so that we can take lessons from what we are missing. I like your quote, do we build the system right and use the system right? I really like it. Thank you for sharing that crisp answer. Let's move to our next question, requirements management. Requirements management and traceability are vital aspects of systems engineering, as you just said. How do you ensure the seamless alignment of project requisites and traceability in complex railway projects?
I think it starts with the point when you write the requirement in the first instance. It's a thing called requirements engineering and systems engineering. It's not I guess requirements management doesn't start after the requirements are written. It should be starting with the engineering of the requirements in the first instance. And I think it comes back to where do the requirements come from and what's the source of the requirements. In infrastructure projects and railway specifically, we typically pick up the requirement set that we had from the last project. We modify it slightly, hoping that it meets our needs, and then we move forward with procurement. But when we go through the real, coming back to the same question we spoke to in the first question, like, did we build the system right and is the system right? I think those two questions cannot be answered unless you have source references. So I think when you're writing a requirement set, it's important to go back to what were the stakeholder requirements? Can we trace requirements back to those stakeholder needs? And what was the operational concept, maintenance concept that we were trying to build to? Can we trace those requirements back to those operations or concepts to meet those needs? The next thing is things like system architecture. In order to meet a client's need or operator's need in delivering the system, we need to create those interactions between humans and the systems, and documenting that such that the operator has clear visibility from the beginning as to what they will be getting at the end is important. And those functional analysis to break the system into functional needs, into assets is important as well. And once we've done that, we link it all to the requirements. And that creates the lead in into the requirement set. And then when you talk about traceability, which is as we progressively work through, once requirements are documented, approved, how do we move to the verification of them? And they take two steps, one in design and one in product verification. And in design, it's that progressive step of going, if I've designed the system, does it meet my requirements need? And can I demonstrate that objectively with evidence? And then secondly, moving into the product verification. When I build my system and I test it, it doesn't meet the requirements as demonstrated. And it also goes back to, did I build the system right? The testing confirms that I built the system to the design and then back to the requirements. And I think those two steps are very important in progressive verification of a requirement set. It also allows you the feedback loop in the design and then again in the product. So let's say, for example, the design doesn't really meet the client's need. For example, they said I wanted a train, but they didn't specify the color. The design specifies the color. The customer reviews that against the train requirement and goes, wait, it's not what I wanted. Can you please change it? You have the opportunity before you've even committed it into a product to go back and actually fix the design. Yep. And as you know, with the cost of engineering, the cost of change increases exponentially as the project moves into delivery. And it's about being able to manage that progressive points in time, not wait until the end, and then realizing the client didn't get what they needed in the first place.
Wow, great insights, Malaeka. Let's move to the one more follow-up question, please. Configuration management. Configuration management is essential for maintaining consistency and integrity in railway systems. How do you handle configuration management challenges, especially when dealing with multiple system components?
Great question. I think it's the question that we don't ask ourselves enough. I mean, we work for government and we have a client need to manage configuration. And then in the contractor side, which we've been on, I think they also have a need to manage the configuration. In my mind, there's configuration baselines. Once you declare them, you have to manage them. So configuration baselines aren't limited to just the design documentation itself. It should be the product linked to the design documentation. It should be the requirements baseline. So if you go through the V life cycle, you have a declaration of requirements baseline, you have a declaration of design baseline, and then you have a declaration of product baseline. Any changes to a declared baseline should be configuration managed. It should be impact assessed against other impacts. Because, for example, let's say I agreed an interface design with another party. It's in the design baseline. During realization of the product, I realized I couldn't get the product. I need to go back to fix the design baseline. And that type of feedback loop and change management is important. And I think even in software areas, it's extremely important to know what configuration you're testing, especially safety rated systems, about going, I've tested version 1.1, I had these failures, I test version 1.2, does it fix the failures? Do I need to do some regression testing? Those version controls and configuration management principles are really key. And we should have a strong process to manage that in our projects to support the alignment of the project at the end. Because most projects start to fail when we get to integration. But the thing is that the integration is the last step. There was steps along the way that were missed that made us get to the point where we're not really sure what we've got at the moment on the baseline that we're testing. And configuration management is the principles to help with that.
I do agree. 100% I agree with you. Malaeka, great answer. Let us elaborate a bit more. Could you elaborate on the significance of operational concept diagrams, which you just in your intro you touched it, in railway systems engineering? How do these diagrams aid in the planning and execution of transportation projects?
Another great question, Rahman. I'm not sure many people are familiar with the concept of model-based systems engineering. It's sometimes confused with interrelationship between requirements and systems engineering in the requirement space to the digital engineering space, which it isn't. In fact, actually, model-based systems engineering starts at the concept phase when you don't really have a solution and you're trying to figure out how your systems and what you need to procure to build a system that meets the needs. And in that space, you have operational concepts, which are scenarios, which is like we were talking about before, how an operator interacts with hardware and software to realize an outcome. So how does someone sitting in an operational control center enable a gate to be opened on a station which is unmanned? And, enabling that process of I need to be able to have a help point next to the gate line. I need to be able to have a button on the OCC desk that enables to open the gate line and then let the customer out. Those type of principles are, they come back to the beginning of the project when we're defining the requirements. If we have a scenario that does that, we can then elicit requirements into the solution space to ensure we meet the operational need. And when we link it together, we always maintain that how we're going to actually get to the end with the operational need, because we've got the scenario mapped to the requirements. Once requirements get verified, we can deliver the scenario. And that interplay and that ongoing management and interrelationship is important. I was fortunate enough to write a paper on this for Incozy,
wow,
which was accepted, which was a great, really proud moment with some of my colleagues and on digital systems. And it really talks about this. So if you're interested, reach out and I'm happy to share the paper.
Yeah, thank you. I got another follow-up question. I'm losing the track because your talk is so engineering, so technical. I love your technical aspects. Let's discuss about design. Interface design description, as you said, is crucial in integrating various system components. How do you approach interface design descriptions to ensure smooth interoperability in railway systems?
It's another good question. I think every discipline has a way of engineering, and what systems engineering is a multidisciplinary engineering approach. It's a common way of working. Now, electrical engineers, civil engineers, signaling engineers, rolling stock engineers, they all have their own way of realizing interfaces and understanding that within the context of what they're doing. So, for example, if you talk to a signaling engineer, they'll talk about how an axle counter may interact with an interlocking system, whereas if you talk to a rolling stock person, they'll talk about how the brake system interfaces with the door system in the train control system. They work through those interfaces quite normally, like it's something that they do as part of their BAU, bread and butter. But when it comes to integration between those parts, that's where we need to take a bigger picture view. So coming up with component breakdowns or physical breakdowns that are common to the project view is really important, because everyone has a mental model of how things come together. And it's about having a common mental model between all the parties on the project. You can't have one person thinking that this part has 5 components and this part has 10 components. The same part has 10 components, because they all should be the same components that we're all talking about. Common language is another one. Like if I'm talking about a brake system, it's called the brake system in all the documentation. It's common. It's not different between each system, each set of documents, each set of suppliers. So I think for me, starting off with common description of components, then linking the components to each other through an interface register that's maintained on the project, and then using that interface register to design the interface and then test the interface. It goes similar to how you would do a system design. I define the system, I design the system, I test the system. And interfaces should be treated similarly. I define the interface, I design the interface, I test the interface.
Great answer, Malaeka. I'm loving it. If it's not a 30 minutes podcast, I would be talking to you for hours together. Let's touch the other important engineering aspect. Engineering change management is pivotal in adapting to evolving project needs. What strategies do you employ to manage changes effectively without compromising systems integrity?
I guess it's one of the wicked problems. I feel like people, when they start the project, they think nothing changes. It maybe works in smaller projects which have a life cycle of maybe a year to 2 years, because the same people who started the project are there at the end to finish it. I guess they have the whole project in their mind. They can manage changes organically. When you compare the typical infrastructure projects with, say, a defense projects, their projects go for some 10, 20 years. They have a turnover, maybe not as high as infrastructure projects, but they do have a turnover. But the project has information model that is retained with the project. Everyone always has a line of sight as to how the system was realized. Change management is similar in that you need to have proper change management put in place from the beginning. Decisions need to be made by the right people who are competent, and they need to be looking at the whole when they're making the decisions. They shouldn't be making decisions for the benefit of one thing or one party. They should be making the decisions for the benefit of everything. And that's where technical integration, which doesn't care about commercial barriers, it doesn't care about schedules, it's always looking at the whole and how the whole comes together. And in strategies to employ that, I think it's about moving away from a few people who have a not common knowledge of what the system is in their heads to document data-driven decision making. So having requirements linked to the source, having requirements where two interfaces are linked to an interface register. Those things are strategies of creating data in the back end to manage changes progressively through the life cycle of the project. Because then you can always go back to why did that requirement exist? Maybe it existed as a control to a hazard. If I delete that requirement, does that mean that I have removed a control that I had got to a point where I had a SFARP argument for a hazard? Do I now need to reevaluate my hazard? But you wouldn't make that decision if you just looked at the requirement in isolation. And that's why having data-driven decision-making, changes and change management progressively in the life cycle is very important.
Beautiful answer, Malaeka. Agree with your answer, because me working from $1 million project now in $1 billion project, this decision making is a key skill. And I have seen a couple of people coming to me and telling that this project is lost. The people have no idea what they're doing. But your answer really clarifies. It's not about looking into one aspect. It's looking into the big picture and making that decision. Thanks for sharing. I don't think many people understand it. Thanks for this great insights. People listening to you would definitely appreciate your answer. Moving to the next question. Establishing processes for product acceptance is critical. Could you share insights into how these processes are structured to ensure compliance with industry standards in railway systems, please?
I think everything's set up at the beginning. I keep referring back to the beginning in every single question. I think if you set the project up for success, it is success. Projects are not set up for success. It's hard. It's hard work throughout the project to get to the end. And you make compromises along the way because it's hard to go back to the beginning to fix something. Context of this question, I feel like, what could be acceptance criteria? It starts with the requirement itself and having a clear requirement that you know what you expect to see at the end for successful verification of that requirement. In systems engineering, we have concepts like verification methods, verification statements that you write together with a requirement. In infrastructure, very poor at this. We barely nominate a verification method. And when we do, we sometimes nominate the same requirement in different contract packages with different verification methods, which goes against what you'd think, because ideally you should be able to read a requirement and go, yeah, I expect to see a demonstration for this, or I expect to see a test for this. And the same requirement appears in 2 or 3 packages, it has a different verification method. You ask the question, well, why is it different? Why does it need to be different? It should be the same. But if I set the verification method up at the end, everyone is clear as to what is successful verification going to look like. What does successful product acceptance look like? If the client is aware that they're going to be only getting a design documentation to support that verification from the beginning, that's fair. And if the thing is, if you haven't agreed the verification method up front, you could have scenarios where the contractor's trying to confirm acceptance through a documentation, but the client was expecting a test. It shouldn't be like, it should be set up from the beginning. And it's important to declare the verification method at the beginning of the project, because it sets a cost for the contractor as well. If I know I have to run a test for 20% of my requirements, it's different to running a test for, say, 50% of the requirements set. And if I know that I have planned for that verification at the end, I would then price it in. But I think when we don't declare that at the beginning of the project, the contractor's like, well, that wasn't an assumption I made. I never assumed I was going to test. And then you end up in dispute about acceptance. It's too late by then. And everyone is clear. Everyone is motivated to finish the job, move on to the next thing. And the client usually accommodates to their detriment because they also want the product to be accepted and move on. But you don't have objective evidence. Just tomorrow, if an inquiry was raised as to where that requirement was verified, you wouldn't have that objective evidence. That's the lack of implementation of systems engineering. I feel like people think that they do systems engineering, but the application is weak. It needs to be improved if we want to say we're doing proper systems engineering on our infrastructure projects.
Beautiful answer, Malaeka. Great answer. I think there's one follow-up question. Once the verification method is done and we found some issues, the follow-up, which generally is a kind of FRACAS, the failure reporting, analysis, and corrective actions system, is a productive approach. How does FRACAS contribute to identifying and rectifying potential issues in railway systems before they escalate?
I think FRACAS is a process It's a good process. I find it works well when it's transparent to all parties involved. It's a proactive process, right? Like as soon as a failure occurs on a test, you go into a process of root cause analysis. And that root cause analysis could be maybe the test step was wrong. The first step usually is, oh no, the system failed because the system is incorrect. Maybe that's not it. Maybe the test step was wrong. Maybe the design was wrong. Maybe the requirement was wrong. When you do the root cause analysis, you can find the answer and then you can rectify it. And if the system is incorrect and it's not built to the design, you can redo the system. But if you need to fix the design, you need to go back a step. And if you need to change the requirement, you need to go back 2 steps. And so that FRACAS system of root cause analysis is quite key. I think it's a good way of documenting all the problems as they're found. As soon as a test fails, you move it into a FRACAS system and it's then triaged through the FRACAS system as to the corrective action that needs to take place in order to rectify. And the sooner you start that process off on a failure, the sooner you get to the solution. It's harder when failures have occurred, they haven't been documented, then the follow-on test fails, it's hard to manage. But if you go that, if I failed on this step, does it mean that I now need to delay the next steps of the testing? Do I need to pause everything or can I progress with testing? As soon as you can do that type of analysis on the failure itself, it helps manage the integration part of the project. FRACAS is really important in integrating systems. Without it, I don't see how we can collectively come to an understanding of the gaps in an integrated solution. It's like you're running blind and trying to put band-aids on the system at the end. It would be better if we were running a process over the top of it and going, no, it's not haphazard. It is an organized way of working.
Well, when we speak about complexities in this FRACAS level, I want to talk about at a system level. So when dealing with complexities in railway infrastructure at a system level, now the main thing is safety. How do you prioritize safety measures within systems engineering and assurance framework?
Another great question, Raymond. I think when we talk about systems engineering and assurance frameworks and that interplay between assurance and systems engineering, I think in assurance we look for 2 questions, especially in railway assurance. One is the system fit for purpose? And the second is the system safe? Now, you could have a system that's safe, which doesn't move. A railway that doesn't move is a safer system. A fit for purpose railway may be 100 kilometers per hour. But the thing is, it's a trade-off between those 2 things. How do I get to a fit for purpose solution that is also so far as reasonable and practical as a framework that we use here in Australia? And so that demonstration comes with systems assurance. And I think the underlying assurance is a check. It's a compliance check. But I think it comes back to how good was the systems engineering set up in the beginning to capture that progressive compliance. The prioritization is always towards safety, naturally, because we work under Rail Safety National Law here in Australia. We want to demonstrate compliance of safety. And that trade-off between safety and fit for purpose needs to be made as an argument and then presented. The framework that we have in transport for New South Wales is quite strong. It gives us that structure. And I think it's common to all systems assurance arguments under European norms, European standards for that definition of systems assurance. I think that complexity helps because when you're making an assurance argument, you do have to make that trade-off decision about safety and fit for purpose in order to realize a solution. You do failure mode analysis, you do testing to demonstrate safety requirements have been delivered. Any failures or any defects, you need to talk about what that means for the safe operation on day one, and then the progressive rectification of the defect to the final end state. And those frameworks are set up with the systems engineering processes that the assurance team checks against.
Well, great answer again. But most of your answers, what I observed is the second side of the V cycle, engineering V cycle, is very, very crucial. So, which most of my career I worked that side. Other question is, it's just like a follow-up question. As a leader in systems engineering, what methodologies or innovative approaches have you implemented to optimize project efficiency and effectiveness in railway systems?
I guess I came from defence in my early career, and in defence, systems engineering is a way of working. Everyone works in the systems engineering framework. When I came to railways, I mean, it's not as structured and process driven, and it comes back to like we were talking about before, where railway projects sometimes have a life cycle of about 1 to 2 years. People start the project, finish the project. They don't need to do documentation management or retention of information to support other people understanding the decisions that were made along the way. As a leader in this area, I think it's about being measured, and I guess the way I would put it is you can't run the same ruler of systems engineering across every single project. If I was doing a type approval project, an implementation of an already type approved project into the railway context, my systems engineering will be very low. It'll be about verification of a type approved product in the context of that particular area. But when I talk about mega projects with, new systems, greenfield railways, you can't apply that same ruler. You should go back to the beginning and try and engineer solutions so you can eliminate hazards. You should go back to engineering solutions such that you can get a more efficient railway, remove the number of parts, remove single points of failure, remove where you move into degraded mode. If one system goes down, how do other systems compensate? How do you come up with a more improved maintenance regime? All these things are life cycle overall, from cradle to grave of the asset. And I think explaining that to people and their role in that process is important. And it's not about throwing the systems engineering word around. It's about how this process improves the project, benefits the people to realize the outcome. And I think if people can see why that is important, how that helps them, I feel like people usually come along on the journey with you. People don't understand what you talk. People have come across bad systems engineers in the past. They will taint you with the same brush. And I've experienced that where people have come across systems engineers who are just, I guess, document doors repository people who just, churn things in and out of doors. But systems engineering isn't requirements management and doors management. It's more than that. Them being able to be experiencing a proper systems engineering project is what I feel like people are missing. Once they see a proper systems engineering project, they will automatically go, yeah, that makes sense, because systems engineering is common sense. It's about why wouldn't you document that?
Correct.
If one person has a mental model of the whole railway, why does one person alone have that mental model? Why can't we all have a common model? And documenting all that down is important to have everyone, some of our young engineers, join us on the journey of systems engineering into the future.
Could you give a small example, particularly a challenging aspect of systems assurance you have encountered in the railway projects, and how did you navigate through it?
Systems assurance is not my, I'm more of a systems engineer than an assurance engineer. In that context, and that difference is something that's in the railway context. It's not necessarily in other industries. But in the systems assurance context, I think it's about progressing when everything isn't perfect. Like when you don't have full compliance, when you don't have safety sorted out, but you want to progress to the next stage. It's always difficult. And I think it's the navigation is something that my current managers taught me about risk management. It's about understanding the risk associated with proceeding at risk and the impacts of that. And if you document that, if you can articulate that in a way that people can understand the risk of proceeding without rectification, it helps everyone understand why we are raising concerns in systems assurance. So risk management, I think, is a key tool in navigating through it. I think that challenge of I want to construct before the design is complete or before the documentation is in place, let the documentation catch up later. It never always works out that way. As soon as someone's constructed it, they've worked towards demobilizing the teams. You can't collect the assurance. It creates other gaps. So it's important to document the risk associated with proceeding at risk and make sure mitigations are in place before you proceed.
Beautifully answered, Malaeka. What I see in overall this talk is collaboration is crucial, especially in the large-scale projects, from what I hear from you. Now, how do I ensure effective collaboration among multidisciplinary teams involved in railway systems development?
I've thought a number of ways. I mean, every time I join a project and you're new, they're a new group of people that you're working with. I think it's always important to build relationships to start with. If people can learn to understand that you have something valuable to add, you bring something to the table, they will then engage you. But your question is quite important in that how do we demonstrate effective collaboration among multidisciplinary teams? Everyone likes to operate in silos because the path of least resistance is working with my people to get the job done. But if everyone is working in their little silos, in their little pyramids, they don't come together at the end. So it's about how do we work from the outside in? How does everyone in the individual silos come together at the end to realize the outcome? I feel like having common tools that are transparent and visible to everyone helps. So for example, if I've got a system asset breakdown structure, it's common, it's shared between the project. Everyone knows where everything is, everyone can find everything. Having a common understanding of how functions works, where the requirements are, where the single source of truth is, making the single source of truth transparent to everyone. I think it's really crucial to bring collaboration into the team, because with silos, people feel like that they can't work. They don't have transparency into that particular thing. But systems engineering, in my mind, is the tool set that breaks down those silos. It sort of taps into everyone needs to work to this common framework. Everyone put your stuff in this common area. We're all working together on this project. We're all going to help solve each other's problems. If I've got a problem in signaling, it's a problem for the project. Maybe track can help, maybe rolling stock can help. How can everyone help each other realize the outcome? And that's how we need to be working in projects. Collaborating, solving problems together, leaving contracts at the door, moving towards solutions.
Beautiful answers, Malaeka. I really love talking to you and discussing to you on this platform. You're bringing great value to this platform. Thanks for coming. And before I let you go, lastly, in your experience, what advice would you give to aspiring systems engineering looking to enter into railways?
It's a big question. I think different people come from different areas into systems engineering, because it's not just necessarily like a discipline that you learn at uni. I've come from a computer systems major at university in engineering, and then I found my way into systems engineering as an undergraduate and then a graduate, and I've never looked back. But some people come from, say, an electrical background or a mechanical background, and then they find their way into systems engineering. If I had to give advice, I feel like there's two parts of this. One is that when you start your career in systems engineering, you actually do understand the processes of systems engineering itself. Like, why do we set the database up in a certain way? Like, a database is a database, not a spreadsheet. But if you're going to use it like a spreadsheet, then you may as well not put it in the database. And how do you structure a database to help inform decision making? It comes back to, you want data-driven decision makings, and you need to set the data up in a way that you can inform decision making along the way. As a systems engineer, you're facilitating the technical SMEs, enabling that proper decision making to be made at the right point in time. And then also metrics, reporting, status accounting, all those aspects of systems engineering and assurance need to be shared with the technical SMEs to help them make the right decisions at the right time. So making sure that they've come through the bottom up, learn the tools, learn the skills before you become a senior leader in systems engineering will definitely give you the benefits of being a good systems engineer in the future. People who come from other areas and haven't got that foundational knowledge, they struggle to give their teams as leaders guidance on how to solve the systems engineering problems. That if they don't have that knowledge, how can they get their team to come to the same caliber of themselves to realize system solutions for the product benefit? The second advice I would give systems engineers is to understand the whole. Don't just think about your project context. If you can help solve the client's problem of the whole, you'll be a more effective systems engineer. Systems engineering is a process to help the clients realize the solution. If you're sitting in your supplier box verifying requirements, you're not understanding the client's problem, how can you help bridge the gap between the two organizations as a good process, as a good systems engineer? And so understanding the whole is very important. And sometimes when you understand the whole, the minute problems that you have within the package can be resolved by the bigger picture view. And I think that's very, very important, being able to look at the bigger picture, help solve the bigger problems, and work through the smaller problems together.
Beautiful, beautiful advice. It's one of the great technical advice on this platform. Malaeka, thank you so much from bottom of my heart. Thanks for joining this platform.
Thank you so much, Raymond, for inviting me. I really enjoyed our chat today.
I believe everyone listening to this podcast has got something to take away from today's discussion. If you like this podcast, please listen, follow, and share this podcast within your network. If you believe we should be sharing your story or someone within your network, there is a railway leader who should be here sharing his or her contribution to this industry, contact me on railwaytransportationsystems@gmail.com. Thank you for your time today. See you next fortnight. Until then, stay safe and take care of yourself.